Alright, you know I said the dimension of any quantity is the relationship of the is the configuration of the quantity in relativity to the MLT, mass, length, and time. Now check this, and I said you have to know the formula, okay, before you can be able to derive the dimension and the unit. So now see, I've given you this three quantity. They are very similar. Speed and velocity are very similar, and velocity is found in acceleration. So I've given the formula already. Now distance does not look like MLT, but who do you think is represented amidst the three? Distance is the gap between 2 points. So it can be mass, it can be time, but it can be length, because length is a measurement from one place to another. So distance can be configured as length. You have transformed distance to length. Then time is already part of our MLT, so that's t. So this is the dimension. But if you don't want to write it like this, you can just write it like this: LT raised power minus 1, because the power of this t is 1. So if you put negativity, it means it's under. Then this is the dimension. So if this is the dimension, to get the unit is very simple. Just what's the unit of the length? Meter. What's the unit of the time? Seconds. And then because it's carrying minus 1, that means per. So you call this one meter per second. Now let's move here. Velocity is displacement all over time. You will notice that I know the formula before. See, you will notice that. So that's for speed. So velocity is displacement over time. Displacement is also a form of length, because it's a distance moved in a specified direction. You can transform it to length. Then length over time give us L3 raised power minus 1 as dimension. Then what's the unit of length? Meter. What's the unit of time? Second square. So speed and velocity are equal because they have the same dimension and the same unit, and they can be used interchangeably in calculations. Then what is acceleration? Acceleration is velocity over time, because we have already gotten velocity to be meter per second, L3 raised power minus 1 in dimension. So just put the dimension over another time. So because another time has involved, the time becomes 2. So L3 raised power minus 2 is the dimension of acceleration. Then the unit will now be meter per second square. Then for force is mass times acceleration. You will notice that I know the formula before I can proceed. So you have to know the formula of these quantities. Then when you now put mass times the dimension of acceleration that we have before here, L3 raised power minus 2, then you have MLT raised power minus 2. Then if you now find the unit of each of these dimensions, you get the unit, kilogram meter per second square. But because the person that derived this formula is Sir Isaac Newton, so we used to call this unit Newton.